These are the D42 notes on theoretical and experimental probabilities. Theoretical probability is what should happen in a situation such as a game. To find a theoretical probability, use the following ratio. You take the number of favorable outcomes out of the total number of possible outcomes. So this is the kind of probability that you did last year and this year yesterday. For example, if you have a spinner with 6 slots for a game, and 3 are red, 2 are blue, and 1 is green. Looking at this spinner, we can calculate the theoretical probability of spinning a red when flicking the spinner during a game. You would take the number of favorable outcomes, or the number of red parts of the spinner, out of the total number of possible outcomes, which would be 6. So the theoretical probability of spinning red would be 3 out of 6. The experimental probability is what actually happens when doing an experiment such as a game. To find the experimental probability, you're going to use the following ratio. The number of times a particular outcome occurred out of the total number of tries or turns. So again, we're creating a fraction similar to the theoretical probability. For example, if we have the same spinner and we flick the spinner 6 times, we have the results below. So in the table, we see for each spin what color was spun. First was red, then blue, blue again, blue a third time, red, and then green. So the experimental probability for spinning a red would be the number of times that the red outcome occurred, which was 2, out of the total number of tries or turns, which was 6. Now turn your notes to the next page. We are going to practice with theoretical and experimental probability. We'll do a short experiment using a coin. The theoretical probability of landing tails on a coin is 1/2, or 50%. We are going to experiment with a coin by tossing the coin 5 times, 20 times, 100 times, and maybe even 200 times if you have enough time. You're going to keep track of how many times you got tails out of the total number of tosses and record it on the line. Then we'll find the experimental probability. Now let's look at an example of an experiment that's already been done. Suppose you have a bag with 75 marbles. 15 are red, 5 white, 25 green, 20 black, and 10 blue. You draw a marble, note its color, and put it back. You do this 75 times with these results. 12 are red, 9 white, 27 green, 17 black, and 10 blue. In the table below, find each probability as a fraction and make sure you put it in simplest form. The experimental probability of getting a red is 12 out of 75, or 4/25. For a white, 9 out of 75, or 3/25. Green, 27 out of 75, or 9/25. Black is 17 out of 75, and blue is 10 out of 75, or 2/15. These are the experimental probabilities, which would be what actually happened when you were taking the marbles out of the bag, out of the total number of trials. The theoretical probability has to do with how many marbles were actually in the bag and what should have theoretically happened. For red, it's 15 out of 75, which equals 1/5. White is 5 out of 75, which equals 1/15. Green is 25 out of 75, which equals 1/3. Black is 20 out of 75, which is 4/15. And blue is 10 out of 75, which equals 2/15. Now we are going to watch a short video on theoretical versus experimental probability.
In this problem, we are trying to determine if we are to spin the spinner 16 times, how many times can we expect the spinner to land on each of the 5 given colors according to theoretical probability? Well, let's examine the green, yellow, and red sections because they are equal in size. We can clearly see that each of these three colors occupies 1/4 of the space of the entire spinner. Therefore, the probability of each of these colors being landed on is 1/4, or one chance out of every 4 spins.
Examining the white and the purple slices, we can see that each one of those occupies 1/8 of the area of the spinner. So we would say the probability of those colors being landed on is 1/8 each, or 1 out of every 8 spins. All of the theoretical probabilities of which we just listed are expressed in lowest terms. We must convert each one of these fractions into 16 because we want to know how many spins out of 16. So all we have to do for green, yellow, and red is to convert the 4 into 16. And for white and purple, we also have to convert the 8 into the 16. When doing this, we can see that 1/4 is equivalent to 4/16, and that 1/8 is equivalent to 2/16. The value of the fractions did not change. However, we expressed it in terms of 16 spins. So for green, yellow, and red, we could expect to land on each one of those colors 4 times out of 16. And for white and purple, we can expect to land on those colors 2 times out of 16. Now, that's only what we expect. If we actually spin the spinner 16 times, more than likely, we will not land on green, yellow, and red exactly 4 times, and white and purple 2 times. That's why we have something called experimental probability. Experimental probability is determined by actually carrying out the action. So let's spin the spinner 16 times so we can determine what the experimental probability is and then compare it to what we expected. Now let's compare the experimental probability to the theoretical probability. For green, we see that it actually occurred 1 time less than what we expected. For yellow, we actually had it occur 2 more times than what we expected. We expected it 4 and we got it 6. For red, we expected it 4 times, but it only occurred 1 time. For white, we expected it twice, but it happened double that, it happened 4 times. And for purple, we expected it twice according to theoretical probability, and it actually happened twice. So purple is the only color for the experimental that matched the theoretical. So remember, theoretical probability is probability based solely on the sample space shown without doing any action or collection of data. Whereas experimental probability is probability based on performing an action and collecting data.